Started?
Started.
Okay, so students, we will be starting calculus today, and we will begin with differential calculus. Okay, you have heard of this? Yes or no? Yes, okay. Good, so I have students. So, even before I start writing any equation, it will be a good idea to develop an intuition for the subject, okay? So I don't want to scare with fancy equations. I want to have a good feel for it. Whatever we are going to write, all those equations, we should have a feeling for it or feel for it beforehand. So let's begin with some observations. And I'm assuming that you have already learned about lines, meaning that you know what the equation of a line is in a plane. Let's say you are looking at xy plane, what the equation of a line is. Okay, so even if you do not know that already, it wouldn't matter, because I'm not going to use that equation. Okay, so in this lecture I think zero equations, but it's going to be very, very crucial in understanding whatever we do later. Okay, and remember, this will be really setting up the foundation for the entire differential calculus. Okay, so you see this image here. That's a mountain. It looks more like a volcano to me, but anyway, let's say it's a mountain, and we'll come back to this picture and you'll see why I have chosen this picture to be here. Okay, so let's start by looking at hills and mountains. They will be extremely useful in understanding the behavior of functions or certain properties of those functions later. And as I said, that I assume that you already know what a line is, okay, what the equation of that is. But anyway, it doesn't matter. So let's start with lines. Okay, I give you one line. Okay, that's strange. That's a line. So I'm looking at x, y. There's some issue. I think.
Don't touch your hand to the wall.
Okay. So that's xy plane, and I have a line in xy plane. Okay. Now this is a line segment. So line will go to infinity in this side. I mean, it will extend to infinity on that side as well. Okay. Now this line, imagine this is part of a hill, and you are going to climb that hill. Okay. And you will face some difficulty in climbing because it has some slope. If you have to, you are feeling cold? We can switch off the AC, no problem. We can switch off the AC. Is it better? Okay, good. So suppose you are walking on this flat horizontal surface. Okay, you don't feel much difficulty, the usual thing. If you are climbing on this one, you feel difficulty because this hill has some slope. Okay, will it be easier to climb on this one or that one? It will be easier to climb on this one. Okay, walking on this is easier because it has a lower slope. This has still a little lower slope. Okay, these are not parallel lines. Okay, and this one has by definition zero slope. So the horizontal line has zero slope. This has slightly more slope, a little more slope, more, and it keeps increasing. And if you look at this one, this is vertically upwards, this has infinite slope. Okay, you cannot climb. Okay, now let's look at this one. Okay, these things are, it's not coming out good. So let's look at, I don't know what mistake I make every time. That's x-axis, that's y-axis. Okay, imagine That's the hill given to you. This, let's look at only this part, don't worry about this, okay? This has some slope. Now I take the same hill and shift it to the right, okay? So if I shift it to the right, this line will get parallelly shifted here, okay? So let's say, I hope it, is it looking parallel? No. It's going to be difficult. But imagine that I am drawing a line parallel to that. Okay? So this, even though it doesn't look like very much, take this one and this one to be the same, okay? So this I have taken and shifted there. Look at the slope of this line and this line. What do you expect? What is the relation between them?
Equal.
Equals. They are equal. These two lines are parallel lines, okay? So even without any equation, you see that parallel lines will have equal slopes, okay? So whatever concept or mathematical expression I develop for telling about slopes, it should ensure that parallel lines have same slopes, okay? So for us, parallel lines have same slopes. Now, you see here, you might already be aware that the slope is positive, okay? How about this one? This line segment, this side. Pay attention here, this one. This one has a positive slope or a negative slope?
Negative.
Negative. You are climbing here and you are climbing down here, okay? So that one has a negative slope. How about this? So this is in the negative side, okay? So that's x, y, that's negative y. This one has positive slope or negative slope?
Positive.
Positive, because you are still climbing up, okay? How about this one?
Negative.
It's negative. How about that one? That's 0, okay? So you have positive and negative slopes. Now, imagine taking this and lifting up, okay, entire thing. So it goes like here. That again creates these parallel lines, right? If this entire thing is shifted up, this will be parallel to that. So that will also have the same slope. This line will have same slope as this line. I'm not worried about the vertical parts, okay? I'm just drawing them so that you see a hill kind of a thing. Okay, another thing, suppose is this okay? Any questions so far? Is that fine? Okay. Okay. Now you tell me, what do you think? I make a triangle, an equilateral triangle. Okay. Assume that these are equilateral, which means this angle and that angle are same, right? If these are equilateral triangles, then these two are same angles. Oh, say loudly.
The upper angle will also be the same, right?
Which triangle?
The upper angle.
That?
No, upper angle.
This?
Yes.
No? That's
Equilateral.
Did I say equilateral?
Yeah.
Oh, I meant isosceles. Only, very good. Okay. I didn't mean, thank you. So I don't need all these three to be equal. All I need is these two to be equal. I think it's called isosceles or isosceles, whatever. Okay. So take these two. I'm sorry they do not look very equal, but take them to be equal. So these two angles are same. That's x-axis, that's y-axis. Now this will have some slope, and it will be, what will be the sign of it?
Positive.
Positive. That one will have some other slope. It will have what sign? Negative. Is there a relation between the slope here and the slope there? It will be negative of each other, right? So if this has slope m, this will have slope minus m. Is that obvious?
Yes.
Okay. Another thing. So we are just gaining some experience with slopes of lines. If you have a line going at 45 degrees. Do you remember what the slope of this line would be? It is 1. You remember y is equal to mx plus c. So m is 1 in this case. Okay, but we don't need to know that the slope is 1. It is some positive number, that is enough for us. Now I am going to give you a mountain, okay, some shape of the mountain, and we want to know the slope. Now for a straight line, you have a unique slope, right? So the slope at every point of that line is the same. So okay. So let's take a mountain. And this is the height of the mountain. Okay, at different places, at different values of x. So let's say the mountain is like this. So I'll draw the mountain here. So there is a straight line. So it has a constant slope. Slope is same as every point, right? If you just look at this much of the line, only this portion, what's the slope? It has some number. If you look at that portion, only that portion, what's the slope? The same number as you had before. At each point, slope is the same. Okay, that's important. Now suppose the hill looks like, or mount, I don't know why it keeps moving. Okay, it should get fixed. Or maybe little better. So imagine that these two have slopes equal in magnitude but opposite in sign. So again, think of if I could extend this, this will make an isosceles triangle. Okay, so what I am saying is this angle and that angle are same. So these lengths are equal. Okay, so that's what I am looking at. Now let's say this is 45 degrees, okay? That's also 45 degrees with respect to this side. Now, you remember the slope is equal to 1 if that angle is 45 degrees. If you don't know this, assume it that it is 1. At least you know it's positive. I'm just telling you the number, the value it has. So it's 1. So here, up to here, it's the height. But now on this side, I am again using the same coordinate system. So this is x. And here what I plot is slope. Slope of the hill or the mountain. Okay. Now let's take these points. Okay. So the point here is the point here. Point here is the point there, and this point. Okay, remember this is x-axis, it's the same axis above. Okay, but the y-axis are different. Here it is height, when you are here it is the slope of the hill. Okay, let's call this as point A, point B, point C, point D. That's also point A. This is also point B. That's C. That's D. Okay, looks like P. Now, what's the slope at this point? It's 1. I told you the slope is 1. If the line makes a 45, if line makes 45 degrees with the x-axis, then the slope is 1. Okay, positive number 1. So let's say slope is 1 here. This is on the vertical axis. I am plotting slope, and that's 1. So at this point, what's the slope? It's 1. It's this. What's the slope here? Sorry, at this point. At this point, the line is here. Slope is still 1. So here also the slope is 1. Here, what's the value of slope? 1. What's the value of slope at this point? At this is the curve corresponding to that point. Slope is 1. So at all these points, the hill or the mountain has slope equal to 1. Okay. So slope is equal to 1. Still 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay. What's the slope here? 0. Very good. So slope is 0 here, 0 here, 0 here. So slope is 0 everywhere. Okay. In this entire region from B to C. So what's the slope here? The slope is here, 0. So that's 0. So you are here. Okay. Slope is 0. Then what's the slope here?
Negative 1.
Minus 1. Very good. Slope is minus 1. So I'll put minus 1 here. And in this region, okay, not this, in this region, the slope becomes, so here is minus 1. Okay. So you see the function, the slope function looks like this. You go here and then the slope is this and this, then the slope is this. Okay. That is what is slope of this hill. Now, if you are able to understand this, and it might be that you are facing difficulty, so think about it. Sleep one night, next day you wake up, maybe you already understand. If still not, maybe one night after that, okay? But yeah, this is going to be extremely useful and make our life very easy when we have other things later. Now let me take another mountain. That mountain, right? It was more like this, our mountain here. It was this straight line, almost flat, almost straight line like this. Okay. Now we will take a different kind of a mountain, and again I want to know what's the slope of that mountain at various points. Okay, that's what I'm interested in. And you might be wondering why I'm so much interested in hills and mountains. And within few minutes we would have covered actually a lot of content, and then we will be writing equations for those in the next video, not in this one. So let's take another mountain. Oh, that's a nice mountain, very roundish. When you have very old mountains, then they are smooth. When you have young mountains, then they are very pointy, right? They have very sharp peaks, and so Himalayas, they are very young. Okay, young doesn't mean 10 years, but they are young on the time scale at which they are young. So you have very, very sharp edges and boundaries and peaks. But as they grow very, very old, then because of air, water, everything, they age, and with age that sharpness goes away. You do not remain that sharp when you are not too young. That happens with mountains also. Okay, so that's a mountain, old guy. My lines are also not straight. Okay, that's x-axis. Now let's see whether we can do this. We don't need, thank you. That's height of the mountain, that's x-axis, okay? We don't need to know exactly what the slope at each point is, okay? All I want to know is roughly what it is. And that's going to be good enough for now, okay? So let's look at, maybe I'll make it little less roundish so let's not take a very old mountain, a little younger than this one. That's better. Okay, let's take few points. A, B, C, D, E, F.
You don't do C's.
Good. Oh my goodness. I think if I have this and do rubbing, then it starts shifting. Okay? Yeah, that's correct. Okay. A, B, C, D, E, F, G, H, I, J, K, L, whatever. Let's take again here the x-axis. So this point and this point here, they are same, okay? So that's same. That's B and so forth. Now tell me whether the slope is positive here or negative. So at point A, the function is this. Is the slope positive or negative? What happened? It's not horizontal, right? Okay. So I can make it horizontal. I think there is a tool which I can use. It's okay. It's okay. We will not worry about all this horizontal, non-horizontal. It's fine. So at point A, this is the function. What is the value of slope? Positive or negative? Forget sign of slope. Positive or negative?
Positive.
Positive. And it has some value. Let's say, so on y-axis I have slope. At this, it has some value. Corresponding to point A, it has some value. It is this. At point B, you are here, the slope has still the positive value, but slope is little less. You see, if I draw a straight line here, oh my goodness. If I draw a straight line here, it will be going like this. But if I draw a straight line here, it is slightly tilted to the right. So it has a little less slope. And you see, as you are going up and up, the slope is getting lower, 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 lower. Here it is 0. Slope is 0 because this line becomes horizontal. Slope is becoming negative now, you see. It is turning negative. So slope is getting negative and slope, the magnitude is increasing. It becomes negative, but its value keeps increasing, okay? So you see, here slope is positive and the value becomes eventually at point F, the slope becomes 0. So slope will be 0 here, so slope will be 0 here, and it keeps decreasing. In some way. Now whether it is decreasing like this, or whether it is decreasing like this, or whether it's decreasing like this, that I am not worried about. Okay, that is something for later. But it is decreasing. At this point slope is 0, but then it starts becoming negative. It's going in this direction. Imagine this straight line, it is having a negative slope. So it starts getting negative, more negative, almost not changing here, it's almost straight. But the point is it becomes negative. So at this point, let's say, the slope is maximum negative, and you see it's becoming negative, 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 okay, and something of that sort. Roughly this is the behavior, okay. Now I will give you an exercise to get a rough behavior. We are not worried about what exactly it looks like, rough behavior, okay. So find out rough behavior of the slope of the following hill. So I am going to give you a very nice hill. Okay, so it's the height on the y-axis, on the x-axis you have x, and the hill is like this. That's how the hill looks. Okay, it's sinusoidal. It's a sine function, but don't worry, I am not interested in exact sine. It looks like this, meaning here you see it's almost straight line. It's changing fast, okay, and then, my goodness, no, I don't know how to bring it, okay. Now the slope keeps decreasing, slope becomes 0. Now slope reverses its sign, it becomes negative, slope is maximum here, right? It's the value, the negative value is maximum here, and the slope is still negative, but it is decreasing in its value, and then it's becoming lower and lower, and then it becomes 0 again. Slope starts increasing again, and it's increasing also in the magnitude. Okay, and its maximum at this point is, from the curve it's visible, it looks like. And then again it remains positive at these points, but it is decreasing again, and the slope becomes 0 here, and the slope again changes the sign, and it has small value, and it starts increasing in the negative direction, it has a negative direction. So plot the slope of this hill as a function of x. Okay, get this, and if you are able to get a good correct behavior, we will be in a very good situation to discuss about differential calculus in a much easy and understandable way. Okay, so that's the homework. Here we will stop, and next we will start differentiating. See you in the next video.